Of you. So today our topic is periodic classification. Okay, so generally this chapter is considered as a foundation for entire inorganic chemistry. Okay, so very important chapter, and let us see what we can learn in this chapter, right? So we'll discuss some very important topics in this chapter. So as of now, we know around 118 names were known. Okay, then elements present after uranium. What is uranium atomic number? 92. Are called transuranic elements. Transuranic elements. And atomic number greater than 100. So elements atomic number greater than 100 are all man-made elements. Man-made elements. So this is introduction of this chapter. Now, how we can classify elements into different categories. The first classification was given by Dobberiner. So first one is Dobberiner Triads. So what is a triad? A series of 3 elements. What is series of 3 elements? Lithium, sodium, potassium. Okay. According to Dobberiner, the atomic mass of the second element, is average of first and second elements. So what is average of atomic masses of first and third elements here? 7 plus 13, and take average, that is 46 by 2, which is equal to 23. So what is atomic mass of sodium? 23. So this is what we call Dobberiner triad. According to him, the average atomic mass of first and third elements is equal to the average, the atomic mass of second element. Similarly, you can try, there are 2 more triads, chlorine, bromine, iodine, calcium, strontium, barium. So all these are Dobberiner triads. Dobberiner triads, right? Now, atomic weight of bromine is equal to the average of chlorine and iodine. And similarly, atomic weight of strontium is equal to the average of atomic mass of calcium and barium. So this is what we call Dobberiner triad. Dobberiner triad, right? So next we'll move to Newland's law of octaves. Newland's law of octaves. So what is Newland's law of octaves, sir? According to Newland, every 8th element will have similar properties as that of the first element. Example, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. By the time of Newland, noble gases were not discovered. So forget about neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Now what you are getting here? Every 8th element. So this is first element. 1, 2, 3. Can count. 1, 2, 3, 4, 5, 6, 7, 8. Now this is a eighth element. Which is eighth element? Sodium. Now these two will exhibit similar properties. Similar if you start from beryllium. If you start from beryllium, then beryllium and magnesium. Eighth element will be magnesium. So these two will exhibit similar properties. This is what we call Newland's law of octaves, right? But this law is applicable up to calcium. What is calcium? Atomic number 20. So after calcium, this law does not hold good for other elements. Understood? So this is Newland's law of octaves. Next, Mendeleev's periodic table. So what is Mendeleev's periodic table? He arranged elements. So in this, elements are arranged in increasing order of atomic weights. Increasing order of atomic weights, right? Then Mendeleev's periodic table, it is also known as short form of periodic table. Short form of periodic table. Okay, next. How many elements are there in this periodic table? 63 elements were arranged in the periodic table, and noble gases were not discovered by the time of Mendeleev, right? Then noble gases are discovered by Ramsay and Raleigh. So they discovered, Raleigh. So they discovered noble gases. Next point regarding noble gases only. Noble gases are isolated from air by using Dewar's method. So noble gases are present in atmospheric air only. So we can isolate those gases from air by using Dewar's method. So this is Mendeleev's periodic table, right? So what was his success? So Mendeleev, he corrected atomic weights of elements like beryllium. He corrected atomic weights of elements like beryllium, right? This is one success. Next. Drawbacks. So what are drawbacks in Mendeleev's periodic table? Position of isotopes. He could not accommodate isotopes in the periodic table, even though he considered elements are arranged in increasing order of atomic weights. So position of isotopes. Next, inverted pairs. Inverted pairs. What are inverted pairs? Argon, potassium. What potassium atomic mass? Mass number is 39. Argon mass number is 40. Okay. Now, according to Mendeleev, atomic numbers should increase, atomic mass should increase. But here, from 40 to 39, atomic mass is decreasing. Atomic mass is decreasing. So this is against to Mendeleev's periodic table, right? So this is what we call inverted pair. These are all drawbacks in Mendeleev's periodic table. Next, modern periodic law. Modern periodic law. So what is modern periodic law, sir? What is modern periodic law? So in this, elements are arranged in increasing order of atomic numbers. Atomic numbers, right? So who determined atomic numbers? Atomic number are determined by Moseley. Okay, by using this expression, square root of nu is equal to a into z minus b. What is nu? Frequency. Frequency of characteristic X-rays. Z is atomic number. A and B are constants. A and B are constants. So this is about modern periodic law, right? Then Niels Bohr constructed long form of periodic table. Long form of periodic table. Did you understand? So this is a long form of periodic table. Who constructed long form of periodic table? Niels Bohr. Niels Bohr. So let us consider long form of periodic table. Long form of periodic table. So in this we have 7 periods and 18 groups. So out of 7 periods, first period, it is known as shortest period. It is known as shortest period because it is having only 2 elements. So what are those first 2 elements in periodic table? Hydrogen and helium. Second and third periods, they are called short periods because they have 8 elements. Next, fourth and fifth periods, they are called long periods because they have 18 elements in each period. And sixth period is termed as longest period. So because it is having 32 elements. And lastly, seventh period. So this is a incomplete period. This is incomplete period. So this is all about long form of periodic table. Long form of periodic table, right? So this long form of periodic table is also known as graphical representation of Aufbau principle because it follows Aufbau principle, right? So that is, it is also known as graphical representation of Aufbau principle, right? So this is regarding long form of periodic table. Then classification of elements into S, P, D, and F blocks. So how we can classify elements into S, P, D, F blocks? Let us see first one, S block elements. So what are S block elements? What are S block elements? S block elements are divided into 2 groups. What are they? First A group and second A group. Okay, first A group elements are called alkali metals. Second A group elements are called
Earth alkali metal.
earth metals, right? So alkali metals general electronic configuration. What is it? NS1. Alkaline earth metals general electronic configuration. NS2, right? So both are metals and they are highly reactive metals. Next one, P block elements. P block elements. So these are divided into 6 groups. What are they? third A group elements. What are third A group elements? They are called boron family. And what is general electronic configuration, sir? Already NS2 is completed, then NP1. Next, fourth A group. This is known as carbon family. And its electronic configuration is NS2, NP2. Next, nitrogen family is also known as nicosens. NS2, NP3. Next, oxygen family. They are called chalcogens. NS2, NP4. Next, halogens. Halogens are called seventh A group. This is a seventh A group. Its general electronic configuration NS2, NP5. So this is fifth A, sixth A. This is seventh A, and lastly eighth A. So these are called noble gases. Okay, and general electronic configuration NS2, NP6. So this is about P block elements. This is all about P block elements. Next, D block elements. Next is D block elements. Right. So what are D block elements? 3D series, 4D series, 5D series, 6D series. Okay. Now, you should know at least 3D series elements. 3D series elements starts from scandium, that is 21, to zinc, 32. Okay. So, this you better remember, scandium to zinc. You may get questions based on this 3D series. Last one, F block elements. Last one is F block elements. So F block elements are divided into two series, 4F series, 5F series. 4F series are called lanthanides. Elements present after lanthanum. 5F series are called actinides. Elements present after actinium. What is D block elements general electronic configuration? N-1D, 1 to 10, NS 2. Whereas here lanthanides. Lanthanide starts from cerium to laptop. Can you hear me, students?
Yes, sir. Excuse me, sir.
Yeah. Now am I audible?
Yes, sir.
Okay. So where are we? F block elements, right?
Yes, sir.
Okay. So let us continue from there. So F block elements are divided into two series, right? What are they? 4F series and 5F series. So what are 4F series? It starts from cerium to lutetium, 58 atomic number, lutetium 71. Whereas 5F series starts from thorium 92, lawrencium 103. Okay, 4F series are called lanthanides, 5F series are called actinides. So this is about F block elements, right? Next, we'll move to periodic properties. Let us move to periodic properties. Okay. Now, how many periodic properties are there? In the first one, atomic radius. Atomic radius. So what is atomic radius, sir? So the distance between center of nucleus and electron density in the outermost shell. In the outermost shell. So that distance is termed as atomic radius. Now we have different types of atomic radii. So how many types are there? In the first one, crystal radius, or this is also known as metallic radius or atomic radius. All are same. Okay, the first type. So the distance, if we consider so the distance, half of the internuclear distance, half of the internuclear distance. So this is nucleus, this is nucleus. Now, half of the internuclear distance is termed as metallic radius or crystal radius. Okay, suppose this is one sodium atom, this is another sodium atom. So the distance between two adjacent sodium atoms, in that half of the internuclear distance. What is it? Half of the internuclear distance. That means distance between two nuclei. Second one, second type. Second type is a covalent radius. Covalent radius. Now, what is covalent radius? Now, if you consider covalent molecule, if you consider a covalent molecule, right? Like this. Okay. Now, this is a chlorine molecule. Let us consider this is a chlorine molecule. This is chlorine atom. This is chlorine atom. Again, half of the internuclear distance. This is half of the internuclear distance. This is what we call covalent radius. Last one, van der Waals radius. What is the last one? Van der Waals radius. So how we can represent van der Waals radius? So we consider two molecules, two covalent molecules, right? Consider two covalent. This is one chlorine molecule. And this is another chlorine So I'm encountering some network issue today. So just try to adjust. Right. Van der Waals radius. So Van der Waals radius is between two adjacent molecules. Between two adjacent molecules. Let us suppose this is one chlorine molecule. This is another chlorine molecule. Right? So these are two chlorine molecules. Okay. Now again, internuclear distance between two adjacent atoms of
Excuse me,
different
sir.
molecules. Yeah, tell me.
Could you please share the screen, sir?
Okay, once again, welcome back. Okay, hope now we don't have any problem. So let us hope so. Okay. Now let us see order of radii. Van der Waals radius is greater than metallic radius. Metallic radius is greater than covalent radius. So which is least radius? So this is least. highest atomic radius is van der Waals radius. This is highest. This is order of radii, right? So next we'll move to ionization potential. What is ionization potential? Energy required to remove electron. Energy required to remove an electron. Okay, that is what we call ionization potential, right? Let us suppose you are having an element, gaseous element, then the energy required to remove one electron, then you will get M plus G plus electron. Again, if you want to remove one more electron from this positive ion, then you need more energy, M plus 2. And you'll get one more. Then the relationship between IP1 and IP2 is IP2 is greater than IP1. IP2 is greater than IP1. So this is about ionization potential. Next, electronegativity. Electronegativity. So what is electronegativity? Tendency of attracting bond pair electrons. Okay. Fluorine is highest electronegative element. Fluorine is highest electronegative element. Oxygen is second highest electronegative element. Okay. So this is about electronegativity. Next, electron affinity. What is electron affinity or electron gain enthalpy? So this is energy released when an electron is added. If you add electron to any gaseous element, then energy is released. That means, let us suppose if you are having a gaseous element M, if electron is added to that, then you will get M minus. But you will get M minus. In addition that, energy will be released. But to add electron to this M minus, then you will get M minus 2. Then you have to supply energy here. You have to supply energy, right? So this is about electron affinity. This is all about electron affinity, right? So these are some important periodic properties. Now let us move to questioning part. So let us see some important questions from this chapter. So that is periodic classification of elements. Periodic classification of elements. From this chapter, usually you'll get 2 questions for CET. And even for NEET also, this chapter is very important. Even for NEET also, this chapter is important. As I said, most of the topics in this chapter will be repeated again and again in entire inorganic chemistry. So let us see some previously asked questions one by one, right? So all these questions will be reasoning type questions and concept oriented questions. So you should be very careful when it comes to application of concepts, right? Let us see. The electronic configuration. The electronic configuration of an element is, this is given electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p3. Okay, now what is, now this is given data. Now question, what is the atomic number of, the element which is just below the above element, in the periodic table, just below the above element in the periodic table. So this is one model. This is one model. So they'll give you electronic configuration of some element like this, and you need to find out the element present above the element and below that element. Right now, in this case, the element just below the above element. That means if, when it comes to the given element, find out what is the element below of that element. So options given are 36, 49, 33 and 34. Right now, let us consider the electronic configuration once again. Let us consider that electronic configuration. What is that? 1s2, 2s2, 2p6, 3s2, 3p3. I'm going to next page. I'm writing that electronic configuration once again. What is that electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p3. So what is this element, sir? This is 3s2, 3p3. Okay. Now, what is this element? Total number of electrons you consider. 3 here, 2 here, 6, 2, 2. So count the total number of electrons here. How many electrons? 2 plus 2, 4 plus 6, 10. 10 plus 2, 12 plus 3, 15. So what is 15th element, sir, in the periodic table?
Phosphorus.
Okay. So which group? Phosphorus belongs to
Nitrogen
family. So nitrogen family. So in nitrogen family, this is the order, right? Nitrogen, phosphorus. And the question is about just below that element. This is a given element. Just below that element, which element is present? Arsenic. So what is atomic number of nitrogen? What is atomic number of nitrogen?
7.
It is 7. Next, phosphorus. This is the sequence, plus 8, 15. Next, arsenic, plus 18. What? 15 plus 18? 33. So what is that? Elements atomic numbers are just below that given element, phosphorus. So which option you will take here? Option 3. So that is 33. What is the 33rd element in the periodic table? Arsenic. Did you understand how to solve these type of questions?
Yes, sir.
Okay, then we'll move to next model. One more different model. Which of the following oxides is most acidic in nature? Is most acidic in nature? So given options are magnesium oxide, beryllium oxide, barium oxide, D, calcium oxide. Okay. Now, if you arrange them in according to periodic table, so you underline those elements. Here it is beryllium, magnesium, barium, calcium. Can you tell me which group elements, all these elements, beryllium, magnesium, barium, calcium?
First group.
First group. First group are alkali. Is there any alkali metal in that? Alkaline earth metal, second A group. Which group, sir? Second A group or second group. What are those elements? Beryllium, magnesium, calcium, strontium, barium. Right. Now, what is the question here? Which of the following oxides is most acidic? The question is most acidic in nature. Now, according to the periodic table, down the group, if you are coming down the group, what happens to basic nature? Down the group, this you should remember. Down the group, basic nature of oxides increases. What will happen? Basic nature of oxides increases. Down the group, basic nature increases means, that means down the group, if you are moving from beryllium to magnesium, basic nature increases. That means beryllium is more acidic in nature. So barium, down the group, basic nature increases means BaO will be most acidic, sorry, most basic. isn't it? Then the first element will be most so among these options, which one is most acidic? Which one is most acidic there? Beryllium oxide. But if the question is about most basic in nature, then what will be your answer?
Barium oxide.
Barium oxide. If it is most basic, it will be barium oxide. If the question is about most acidic, the first element, that is beryllium oxide. Did you understand?
Yes, sir.
Okay. Next, we'll proceed. We'll proceed then. Next question. Which are the following orders of? Which are the following orders? Which of the following orders of ionic radii? Orders of ionic radii is correctly represented. This is different model, correctly represented. Okay, options given are H minus greater than, H plus greater than H. Second option, Na plus greater than, F minus greater than, O minus 2. Okay. Next, third option, F minus greater than, O minus 2 greater than, Na plus. And last option, Al plus 3 greater than, Mg plus 2 greater than, N minus 3. So among these, which one will be following order of ionic radii? Order of ionic radii. Let us suppose if we consider first option, H minus H plus H. Okay, anion will be more in size when compared with neutral than H plus. But here what is given order? H minus is greater than H plus. Here it should be H. Then it will be correct. Then it will be correct. If it is here H plus, then this order will be correct. But it is not present in that order. So first option is ruled out. Second option, Na plus F minus O minus 2. Okay. Now here, what is charge present on all these elements? I am considering here Na plus F minus O minus 2. If we consider number of electrons, how many electrons are there for in Na plus? Actually 11, plus indicates loss of 1 electron. So 10 electrons in Na plus, F minus, fluorine 9. Negative sign indicates addition of electrons. How many added electrons are added here? 1. So here also you are getting 10 electrons. Oxygen, actually 8 electrons should be present, but negative 2. That means addition of 2 more electrons. That is 10 electrons. So now all elements are having same number of electrons. So these are called, yesterday we discussed,
Isoelectronic.
They're all isoelectronic. They're having same number of electrons. Now, number of protons, you tell me. Sodium, number of protons, atomic number, 11 protons here, 9 protons here, and oxygen, 8 protons, right? So, who is having more number of protons? Sodium. So 11 protons means they can attract more strongly these 10 electrons. Whereas here 9 protons means 9 protons cannot attract 10 electrons towards itself. So it can, its size will be more than Na plus. Its size will be more than Na plus than oxygen. But here what is given? Na plus size is more. Na plus sodium ion size is more. But in this order, Na plus at ionic sites will be less than. Will be, Na plus 10 electrons are there, 11 protons. That means it will attract more strongly. Then what will be the size of Na plus? Less than fluorine. 10 electrons, 9 protons. So it cannot attract those electrons more strongly. So it will be less than sodium. And fluoride ion is more much greater than here. Here 8 protons here and 10 electrons here. Can it attract those 10 electrons strongly? So which one will be more in ionic size? F minus. F minus will be more than that of oxygen, right? So this will be O minus 2. So this is not following this order. Next case, F minus greater than O minus 2 greater than Na plus. Now here let us consider same here. F minus O minus 2 Na plus. So F minus number of electrons. No need to calculate, already we have how many electrons. These are having electrons. Okay. So we'll start from that third option, right? F minus O minus 2 Na plus. F minus number of electrons. How many electrons? 10 electrons here. O minus 2, 10 electrons. Sodium, 10 electrons. So iselectronic species. Number of protons, 9, 8, 11. So fluorine is having 9 protons and oxygen is having 8 protons. So we can easily understand here more number of protons present in F minus. So they can attract more strongly these 10 electrons than oxygen. So it can attract means its size will decrease. That means F minus is less than O minus 2. But when it comes to Na plus, it is having 11 protons. 11 protons can attract more strongly, more strongly. So what does that mean? Na plus will be having lesser size than that of oxygen. So O minus 2 will be greater than Na plus ion. So this will not work out here. So next, Al plus 3, Mg plus 2, and N minus 3. Nitride ion. So let us see, let us check here. Number of electrons. Aluminium 13 minus 3, that is 10 electrons. Here magnesium 12 minus 2, that is also 10 electrons. Nitrogen, negative sign indicates addition of electrons, that means 7 plus 3. So all are having again 10 electrons here. Then number of protons you check. Number of protons, aluminium 13, magnesium 12, nitrogen 7. So 13 electrons pulling 10 electrons. So they can pull electrons more strongly towards itself. What does that mean? Aluminium can pull electrons more strongly towards the nucleus. That means aluminium size will be less than that of
Magnesium.
magnesium, right? So aluminum will have more size or lesser size than magnesium. Is it going to have large atomic size or large ionic size or less ionic size? What you are going to have here?
Less ionic size, sir.
Because aluminum is having a more effective nuclear charge here. As effective nuclear charge increases, ionic size decreases. So who is having more effective nuclear charge here? Aluminum. So it can attract those 10 electrons very strongly towards the nucleus. That means the ionic size is decreasing. So Al plus 3 is less than Mg plus 2. And Mg plus 2 is having 12 protons, and nitride ion is having 7 protons. Whose effective nuclear charge is more again here? Magnesium. So it can pull the electrons more strongly than nitrogen. So magnesium ion will be lesser ionic size than nitride ion. So this order will be correct. So Al plus 3 is less than, Mg plus 2 is less than N minus 3. So what is generalization here? Effective nuclear charge. This is generalization. Effective nuclear charge is, if effective nuclear charge is increasing, then atomic size is increasing or decreasing. If effective nuclear charge is increasing, then what happens to its ionic size? Its ionic size is decreasing. That means effective nuclear charge is inversely proportional to size of ion. That means as the effective nuclear charge increases, size of ion will decrease. So they are inversely proportional to each other. They are inversely proportional to each other, right? So this is one very frequently asking question. One very frequently asking question, right? Next question, based on ionization enthalpy. What is that based on ionization enthalpy? This is a different model again. This is very different model. So let us see that question. Among the elements with following electronic configurations, with the following electronic configurations, which one of them may have the highest ionization energy, the highest ionization energy. So let us find out. What are options given? A, neon, 3s2, 3p2. Second option, argon, 3d10, 4s2, 4p3. Third option, neon, 3s2, 3p1. And lastly, neon, 3s2, 3p3. The question is about which of them may have the highest ionization energy. Highest ionization energy we need to determine here. So what is ionization energy? What is ionization energy? The amount of energy required. What is ionization energy, sir? Amount of energy required to remove an electron. So energy required to remove an electron. To remove an electron. So this is what we call ionization energy. Now, among those given options, which is having highest ionization energy, So what we can say there?
I think argon.
Which option you tell?
Option B, sir.
Option B. Why is it so? Why are saying
in that we are having so many electrons, sir. So we can easily to remove.
We can easily remove. No, highest ionization energy means we need more energy. Highest ionization means we need more energy to remove electrons. That means in which case the removal of electrons is more difficult. That is exact meaning of that question. In which case it is very difficult to remove electrons. Highest ionization energy means We need some extra energy, highest amount of energy to remove an electron. If we are using highest amount of energy, what does that mean? It means that removal of electron is very difficult, in which case the removal of electron is difficult, right? So here, fourth option is correct. Why is it so, sir? Let us justify our answer. Why is it? So it is given as neon. What is electronic configuration? 3s2, 3p3. Now, outermost configuration, what is given? 3s2, 3p3. This is outermost shell. Now 3s2 is completely filled. What is 3s2? Completely filled. Whereas 3p3 is half filled. What is 3p3? Half filled. In both the cases, completely filled and half filled electronic configurations are more stable. They are most stable electronic configuration. If they are more stable, then it is difficult to remove electrons. It is difficult to remove electrons. That means we need more energy. We need excess energy to remove those electrons. We need excess energy to remove those electrons. So this is why fourth option requires highest ionization energy. Why they need highest energy to remove those electrons? Because they are having completely filled and half filled electronic configuration, and completely filled half filled electronic configuration is more stable. That means it is very difficult to remove electrons from those orbitals. That is your answer. So correct option is D. Did you understand?
Yes, sir.
Okay. Next, one more question. Write down next question. Among the following, which of the following has the smallest size? Which of the following has the smallest size? Options given are Al plus 3, second option, F minus, third option, Na plus, fourth option, Mg plus 2. So you can find, I'm writing all those ions once again. Just I'm taking them once again. Al plus 3, F minus, Na plus, Mg plus 2. You can see clearly, if you find out number of electrons, all of them are having 10 electrons only. So what are they? Again, the given example, the given question is based on isoelectronic series. They're all isoelectronic. Then effective nuclear charge. Let us consider their atomic numbers. Aluminium 13, fluorine 9, sodium 11, magnesium 12. We need a smallest. We need smallest size. As what is that previously given relationship? Effective nuclear charge is inversely proportional to size of ion. Hence again, I'm taking the same relationship. Effective nuclear charge is inversely proportional to size of ion. What size we need, sir? Smallest. Inversely proportional means if you are taking this parameter as smallest, then effective nuclear should be highest. If you need smallest ion, then effective nuclear charge should be highest. Where you can find highest effective nuclear charge in the given options. 13 is highest effective nuclear charge. So which ion is smallest here? Al plus 3. Which ion is smallest here? Al plus 3. So this is about size of ions. Size of ions. Did you understand?
Sir,
Yes, tell me.
AL3 plus 8 barutte. How did you get it small, sir?
How did you get it? Okay, I will explain you. So maybe you're not getting that concept. This is nuclear charge, right? So in the orbits, electrons are revolving. In the orbits, electrons are revolving, right? Now total, how many electrons are there?
13.
Electrons.
10, sir.
10 electrons, right? Now, here we have 10 electrons. Effective nuclear charge, here, nuclear charge. Here, how many protons are there?
13 prot.
13, right? So,
Yes, sir.
this is 13, this is 10. Okay, now 13 protons, strength is more than that of 10 electrons, isn't it? Whose strength
Yes,
is
sir.
more? Effective nuclear charge strength is more. So what it will do? Protons will attract electrons. As the strength of proton is more, they can attract these electrons towards the nucleus. That means as the strength of protons is more, they can pull these electrons towards the nucleus. If the electrons are coming towards the nucleus, if the electrons are coming towards the nucleus like this, they're coming towards the nucleus like this, they are coming, right? Then what is happening to the size? What is happening to the size? Size is decreasing.
Decrease.
The more strongly you pull the electrons, the more the size will decrease, isn't it? Now you understood?
Yes, sir.
Okay, so this is a very frequently asking question. So hope your doubt is clear now.
Yes, sir.
Okay, so practice as many questions as possible. Okay. Okay, one more question. This is one frequently asked question. Then we'll wind up this session. Which one of the following is correct? Which one of the following is correct? Correct order of the size of iodine species. Iodine species. Okay, this is given. I plus greater than I minus greater than I. Next, I minus greater than I plus. Next option, I greater than I minus greater than I plus. Last option, iodine greater than I plus and iodide. Now, which is correct order of iodine species in terms of size? In terms of size. So, always remember that what you should remember, sir, anion's size is greater than neutral atom, neutral atom. Neutral atom size is greater than cation. This is the order you should remember. This is the order you should remember. So according to this order, anions, suppose X minus is greater than neutral, is greater than X plus. Now you place any species in this order. Here, which species we are considering? Iodine. So what will be the order? I minus greater than I greater than I plus. Is it clear now?
Yes, sir.
Okay, this is easy to remember, right? What you need to remember, this order. If same species is present but different ionic forms, cation, anion, and neutral, then this is the order. Anion will generally have more size than neutral atom. Neutral atom will have more size than cation, Then you can arrange in order easily. Did you understand?
Yes, sir.
Okay, so these are some important models in this chapter. So tomorrow we'll go for chemical bonding and we'll discuss as usual some important questions from the chapter also, right? So meet you tomorrow again. So till then, it's good night for all of you.
Thank you, sir.
Okay.
Thank you, sir.